Hello, SAM fans, and welcome to this SAM Science Physics edition of Weight, Mass and Gravity. This is suitable for foundation, higher and triple. Now, a common mistake that a lot of students make in exams, and even when they're talking about it, is the difference between weight, mass and actually what gravity is. So if I was to ask a student, what's the difference between weight and mass? A lot of the times they would really struggle to define the difference between the two. If I said to them, what's gravity? Again, a lot of them would struggle as well. So this is really important content for all three tiers for the GCSE physics. So let's get cracking. So first of all, in case you didn't know, this was how people used to fix light bulbs into ceilings before Newton came along and invented gravity. This is actually a true story, and this is actually a real picture that's been taken. So it's not fake, it's actually real. So just a very quick brief history on Newton. So as it says there, the story goes, he was sitting under a tree, an apple tree to be precise. We got to know the name of the fruit, it's an apple. And then the apple then fell on his head, and then he went on to explore why that happened, where that came from. And then there was a theory that came out of it in the end. Don't worry too much about that mathematical equation, because I know that a lot of people hate maths, and maths makes people cry. And he actually named that gravity itself. And that is a cartoon version of Mr. Newton himself. So that's basically where gravity had come from. So gravity, first of all, on Earth causes, for example, this man here to accelerate downwards towards the center of the Earth. And its effect is the same everywhere, okay? Everywhere on Earth. Okay, common question. Which is heavier, 1 kg of hay or 1 kg of bricks? This is tricky on this one, is very tricky. So actually they're both the same mass, they're the same heaviness, if you like, and the reason being is because they're both 1 kg, so they're both the same mass. Okay, so it doesn't matter if it's bricks, nails, concrete. If it's 1 kg and it's 1 kg of feathers, it's going to be exactly the same heaviness. Okay, and then this brings us on to mass, exactly what mass is. So the reason why they're not as heavy as each other is because they've got the same mass. Okay, so what is mass? So it's basically the measure of how much particles an object has. So it's basically the amount of stuff that an object is made from itself. It can't change. Okay, so mass is the same everywhere. Okay, so your mass will not change. Same everywhere, as I mentioned, and it's measured in kg or in grams. Okay, now if you were to go to outer space, you go to go on the moon, go to Jupiter, you go to any planet outside of Earth, your mass will not change. It will remain the same. Okay, but then we come on to this next one, which is weight. So the next common mistake is that students, as I said before, cannot define what weight is. Now, weight is actually a measurement of how strong gravity pulls on a particular object. So when people say I weigh 10 kg or 50 kg, what they actually mean is the amount of gravity pulling on them on the Earth is actually 10 newtons or 50 newtons, because weight is measured in newtons. It's not measured in kg. Okay, so this is why people's weight changes. They might find they lose weight, or they might find they gain weight. And the reason being, it's the amount of force on gravity. So if they, in inverted commas, lose weight, actually means that gravity isn't pulling on them as hard, if you like, as if they were to gain weight. Okay, so the heavier the mass, the more mass an object has, the more gravity is pulling on a particular object. Okay, now people don't understand newtons, so no one's going to say I weigh 50 newtons, hence why people say I weigh 50 stone or 50 kg, simply because no one actually understands that phenomenon of newtons. And that can change, okay, depending on obviously where the object is. If we're out in outer space in the moon, for example, that will change, okay, because gravity is different outside of the Earth. That's measured in newtons. So as I said there, if you travel to the moon, gravity is weaker there. What will change? So you'll be basically bouncing up and down on the moon, okay, and that's because gravity is a lot weaker. Gravity is not able to keep you stable or to keep astronauts stable on the moon. You'll be sort of bouncing up and down, probably walking much more slower, and that's because gravity isn't steady there. It's so much more weaker than it is on Earth. Okay, so had to throw in a meme there. Yeah, want to lose weight, go to the moon. Do you get it? Because gravity's weak on the moon. Going on a diet makes you lose mass. Okay, so this will make you sound smart to other people. So do whip that one out at a party. I guarantee you it will make you sound really, really smart. Okay, so this equation came up in my video of physics equations. So this is weight, mass, and gravity. It's probably one of the easiest ones to remember. Again, I put it in the triangle. Remember, whatever it is you're trying to work out, you cover it up. So if you want to try and work out weight, you do mass times gravity. Please do remember it in that way, because if you get asked a question, what's the link between gravity, mass, and weight? If you rearrange it incorrectly, so if you put mass equals weight divided by gravity, you're actually going to get that wrong, okay? Because the examiner wants you to have, obviously in this case, now that exam has been cancelled, your teacher would need to, is expecting you to have weight equals mass times gravity. So just remember that weight is a force as well. Weight and weight's a force that, remember, pulls us towards the Earth as well. And that's weight and gravity can be used interchangeably with one another. Okay, and kg, remember, is your mass, or in grams. If they give it to you in grams, make sure you convert it. Okay, so Sam, that's me, has a mass of 80 kg, but when will she weigh more? Am I going to weigh more on the moon, or am I going to weigh more on Earth? Now, gravity equals 10. Now, in case you didn't know, the Earth's gravity is actually 9.81, but we round it up to 10 because it's easier to work with. So if you're not given the gravity strength in an exam question, always use 10. Unless the question says 9.81, use 10 always, okay? And they may not necessarily give you the number 10 of gravity, the gravity field strength in the exam, okay? Because they're expecting you to remember that off by heart. Okay, so if we know that gravity is 10, we rounded it up to 10. Okay, but now on the moon it's 1.5. Now they are obviously going to give you the gravity strength of the moon because they're not expecting you to know that. And it could be Jupiter, it could be any planet. So obviously gravity is bigger on Earth. So what do? So going back to that yellow equation, weight equals 80 times 10. Okay, because where did I get that from? 80 kg, that's my mass, times it by the gravity, which we know is 10. However, for the moon, it's 80. Remember, my mass isn't going to change, times the gravity strength, which is 1.5 in this situation. What's the answer? So 120 newtons on the moon, however, 800 newtons on the Earth. Okay, so all I did is I took those numbers, this is unrearranged, and I times them with each other. Okay, remembering, of course, that weight is measured in newtons. And then there is your answers. Please make sure that you do show your working out as well. Thank you very much, Sam fans, for watching this video. Please do like and subscribe, and do check out my other physics videos as well. Just because formal GCSEs are not taking place does not necessarily mean that you don't need to know this information as well.